Alright guys, today we are going to talk about section 2.3, which is writing equations given a point and a slope. So far we know standard form, which we're going to see again today, slope-intercept form, which we'll see, um, but this time we're going to start with point-slope form. Alright, now hopefully you've seen this. If not, here is point-slope form. Y minus y1 equals m times x minus x1. Sorry guys, it's a little different from what I've done before. I'm trying to do it right on the computer, so bear with me now. All right, so this form right here is really simple to use because all you need is the slope and a point to create an equation, and we're going to be able to put it into slope-intercept form. So this y here and this x value, those are like the x and y value you see in y equals mx plus b. The y1 and the x1, that's the coordinate of your point that you're given, and obviously m is the slope. So the first example, it gives you what the slope is, it gives you a point, you're just going to plug it in. So y minus, the y1 value is 7, so y minus 7 equals m, which is negative 4. Oops. Maybe I can get this. Negative 4 times x minus x1, which x1 is negative 1. Well, what we know is when we see that minus a negative really means plus. So it's really x plus 1 here. All right, so now, once you have it plugged into the formula, all you do is distribute. And now we have y minus 7 equals negative 4m. Sorry, negative 4x. My fault. Negative 4x plus negative 4, right? Because we distributed this negative 4 to the 1. Now, all you have to do is move the 7 over, so you're going to add 7 right from this side to here. And now you have y equals negative 4x plus 3. So, a couple steps. Plug in, distribute, and then isolate the y by adding or subtracting whatever's over here. Now remember, it's always subtraction, subtraction. If you end up with minus and negative, then you can change it to plus, okay? So be careful with that. Don't fret over here. I will post the key to this, but I want you to see the process. All right, now, if you're given 2 points, first thing you have to do is actually find the slope, which m equals, that's supposed to be an m. M equals y2 minus y1, which you've seen this formula before, over x2 minus, keep grabbing it, x1. Once you plug this in, you're able to find the point slope formula, which you take your m value, and you can take either the x1 or y1 coordinate or the x2, y2 coordinate and use that as your point you plug in. So let's do one of these examples here. Let's try number 4. Okay. So first thing, you find your slope. So you do y2 minus y1. Okay, so 8 minus negative 2 is really 10. So I'm going to put m equals, let's do this, m equals 10 over, whoa, that was weird, delete that. 10 over, now x2, -6, minus -2, so -6 minus the -2 is really +2, so that is -4, which we know we can simplify down. We get -5 halves. -5 over 2. That is your slope. Okay, now take your slope, plug it into your point slope formula right here. Now you can take either one of these coordinates, this one or this one. I think I'm going to take this one, this first one, just because I think the numbers are easier. Even though there's subtraction, when you plug it in, it'll be minus and negative, so it'll make it plus. So y minus y1, so minus -2 is really +2, equals the slope we just found out was -5 over 2. It's supposed to be -5. Let's try that again. -5 over 2 times x minus x1, so minus a -2, which is really +2. And now we distribute. Take one here, take it here. Y plus 2 equals -5 halves x. I don't know why it keeps doing that. -5 halves x. Or sorry, yep, 5 halves x. And now -5 halves times 2 really gives us, where are we at? -5. Perfect. Now, last thing, take this 2, right? It's +2 here. Move it over. So instead of, so you're going to subtract 2 from both sides, and your final answer for number 4 is going to be y equals -5 halves x Sorry, this is taking so long, guys. Not the best method. -7 after we move the 2 over. So that's your answer. So you went from finding the slope to point slope form to just distributive property, which we're all pretty good with, and then moving the variable over. Okay? So you can practice on those. I'm also going to post a key so you can see the problems being done. Now, coming down here to linear equations. What you're going to do is you're going to write equations in slope-intercept form. Okay? So here is a matter of you understanding what we're trying to accomplish here. So it says write an equation to represent the cab fare. So the cab fare is what we're trying to find. So we're going to say C equals. So a cab ride costs $4 plus $1.75 per mile driven. All right. So we for sure know we have to pay $4 for a cab ride, no matter what. Okay? $4 plus however many miles we go. Well, there's our unknown, right? So this is $1.75 times the number of miles. Now, obviously, your variables don't matter, but I mean, it makes sense to use letters that represent what we're looking at. Okay, so in this case, C equals 4 plus 1.7 times M. Now, part B of this. It says if Clay's destination is 17 miles away and he has $30, will he make it? So what we need to do is figure out how much it's going to cost. So for sure we know C equals the $4 charge plus 1.75 times the miles, which we kind of know our miles, right? So instead of M, We're going to put 17 here. Now, we're going to make sure that this is less than, it's less than 30 bucks. So, plug it in your calculator, and you should come up with the cab fare equaling, oops, delete, $33.75. Which, obviously, will he make it? No. Looks like Clay is going to have to hoof it for a little while. So, that's how you do that. All right, now, look at the examples for the next few. Be careful when you see things like this, 3%. We know in equations, we don't use the percent value, we actually use the decimal value. So, in this one, just so you know, your equation is going to look like 0.03. Oops, that should be a 3 there. 0.03 times some value, right? I'm just going to put P because it looks like it's 3% of a purchase price. So just know in that equation, as you look at it, that's what's going to happen, okay? Now look at standard form. Excuse me, sorry guys, I think I'm getting sick right now. So standard form, remember what we want to do is we have two variables and they're equaling a constant, okay? So number 10, Josh bought 3 bags of potting soil, 10 bags of mulch from Home Depot. Write an equation to represent the total cost. All right, so we know in standard form it's AX plus BY equals C. So this is perfect, equals C, cost. Okay, now the two things that we have are $3 for potting soil plus $10 for mulch. There it is. Okay, now that's how I do. You have to define what you're looking at. Okay, so potting soil is our first variable, what changes. Mulch is the second one, that's what changes also. Okay, and we're trying to find total cost. Now, you can plug this in, trying to figure out, like this next one, it says that Josh spent $40.91. It tells you exactly how much he spent. That's your total cost. All right, $40.91. Now he got that. Cost $2.75 per bag. How much was a bag of potting soil? So here, $3 for every bag of potting soil. Okay, plus 10 bags of the mulch, which we know cost $2.75. So we just replaced the M value with what it tells us it is. Okay, so you plug this in and you solve for P. It becomes like a two-step equation. This is 10 times 275, which move the decimal over, that's 2750. Subtract it, divide by 3, and you'll figure exactly how much it costs. Okay? All right, so what I want you to do on these ones is I just want you to go through and look at the other examples and then do the best you can on the homework assignment. All right? And when you're done with that, or if you don't finish that, that's what you have to do tonight. Tomorrow I'll take questions about what we talked about here. Okay? All right, guys. Good luck. And like I said, if you have any questions, you can always email me. It comes right to my phone, and I'll know exactly when and what you have for questions on. All right. We'll see you tomorrow.